I should also mention that it's a collaboration also with Esra Mungan and Yazici University Istanbul. And so this presentation has two parts. First, it's about, so the basic problem of this research is about the segmentation of monodies. And we show a state-of-the-art very quickly of the computational model for segmentation of monody, especially two important models that have been considered Tene-Polanski and Emilio Scapuropoulos' local boundary detection model. And based on the discussion about these models, we propose a new model that will try to offer an exhaustive list of segmentation candidates with their strengths and also show temporal location of the boundaries. And so it will be compared empirically on traditional Turkish music. And so the first model we will show is the Tene-Polanski model. And basically, the idea, if you have monody with a succession of musical descriptions, such as, we will consider different dimensions, such as inter-onset intervals. And then Tene-Polanski model is trying to find local minimum on this succession of, let's say, duration, inter-onset duration. And so here, for instance, because you have this interval that is larger than the previous and then the next one, then you have a segmentation here. And so then you can have the same for inter-pitch interval, and here, for instance, this third interval is higher than the previous unison and the next second interval, so you have a segmentation here. And then the question is, could we combine this, and for instance combine inter-onset dimension and inter-pitch dimension? And what is proposed in the model is to sum the elementary intervals using weights for the summation. And this is just an example for explanation. It's not really like this. But let's suppose we sum these. For instance, 3 is 3 eighth note for this interval, and 7 is the fact that you have a 7th interval. And let's sum together for each interval. And then we could see maybe that here you have a local maxima in the summation, and so we could segment here. But then, depending on the weight, you can have very different results, and sometimes strange results, such as here you could have segmentation here. And so now, and this is also a question: can we really think about summing an inter-pitch interval, inter-onset interval altogether? Does it really make sense, and so on? So a big problem. And so basically, maybe I could show at that point, this is an example of this traditional Turkish makam we were considering to see the validation of the model. So I could play you one of these makam that you will also mention afterwards. And so this is a piano roll representation this time. So you have the temporal evolution of the music with the pitch level and the different notes. So if I quickly play the beginning of that piece. There we are. I should mention here that it's actually it's a MIDI file that has been played using some sequencer. And in this example of Tene-Polanski, you can have some chaotic behavior because sometimes some segmentation can be missed just because you have the next interval is the same size than the current one. And also you can have false segmentation, so segmentation that would not be considered as correct just because you have two successive intervals that have just a tiny change. Because it's very binary decision in Tene-Polanski. And also then you have a second level segmentation. If you have this first segmentation into these clans that we just saw, then each of these clans is considered basically as a note, and you have the duration of this clang, and you can try to find our local maxima of these lengths again. So you have a new segmentation higher level. Here it was very well that if just because the last clang of that phrase was longer than the previous and the next, but it's not always the case. So actually it doesn't work in general. So basically for Tony-Polanski, there is a lot of segments. The hierarchy doesn't work in general. And there is no strength, numerical strength related to the segment decision. And so for the intervals are compared to previous and next one, and the summation of the intervals. So Camboropoulos has proposed in a way ideas to go further the limitation of Tony-Polanski. So then now he proposed numerical distance that can enable to have a numerical description of the summation. And this is basically comparing the successive intervals, like using this degree of change interval description. And then there is a segmentation if you have two successive degree of change, high degree of change. For instance, here, this interval is very different from the previous and the next, and this interval is also a large interval. So you have also the size of the interval that is considered. So you have these three factors, and this gives you a numerical value, a curve, where you can see important segmentation when you have high values. And this has been shown as a nice model to show the global segmentation, because you can see high values. You need to fix a threshold to see which segmentation are the most important. But for going more into detail, then there is a problem of the combination of these different factors. Then it's difficult to see if it is due to the previous interval or to the next interval or to the size of the current interval. And then there is the problem again of how to combine these different dimensions. And let's say we have these three dimensions, inter-onset, inter-pitch, and also rest. And again, the summation depends on the weights that you will give to the summation. So if I try, just an example, here we can have a possible segmentation. But with another weight, then we could have some other description, and sometimes this will not work in general. That's for this reason we propose another approach where instead of using a threshold, there is the idea of having an exhaustive list of segmentation. For each of these segmentation, we indicate, a numerical strength. And for that purpose, the idea is, maybe I will go further, to, instead of comparing the interval with the previous and the next, just to look between the current interval and the previous one, simply. And for instance, here we say, okay, this interval is larger than the previous one, so we segment. And we can see that for this example, we can segment here because we have a larger interval, and we don't need actually to see what is the next one to infer a segmentation. So I will go quickly because not so much time. But basically, for interpitch, there is also a threshold, so we shouldn't segment if there is just from a second interval to the third interval. It's not such a big change, so it should be higher, this difference of interval. Maybe the last important aspect of the model is to show a location of boundaries. So let's see on these three first nodes, just based on inter-onset interval. The third, we have here eighth nodes followed by a half node in English. So basically, the idea is that we could have a first segmentation here, just after the half nodes, the beginning of the half nodes, as a duration of eighth nodes. Why? Because there is a kind of succession of eighth nodes, so we would expect another eighth node. And because this half node is not a eighth node, just at the end of this duration of eighth node, you could have this idea of boundary because there is not this expected eighth node. So that gives one possible boundary, but then there is a kind of different degree of granularity, hierarchical segmentation. So then there could be a second boundary a little after in that same node, saying it's not a succession of eighth node, but the previous sequence have a given series of duration, and these durations then are followed by a longer duration. Maybe I can't explain all in detail, but basically it gives a series of possible segmentation with temporal location. Okay, and so then it will be implemented and available in the new software and developing a mining suite where you would have also this different segmentation model. So maybe let's go to the second part of the talk.
So, the goal of the empirical part of this research was initially to see how Makam music trained musicians and culturally exposed but untrained non-musicians taking on unfamiliar tunes from Turkish Makam music. And secondly, how the predictions of these computational models overlapped with this empirical data. Since we have a limited time, we will give only some basic information about the procedure of the experiment and skip the details for now. And so, 16 musicians who were undergraduate students from Istanbul Technical University, Turkish Music Conservatory, with an average of 8 years of Makam music training, built on an average of 3.9 years of general music training, and also 14 non-musicians from Boğaziçi University with an average of 0.5 years of general, but especially not Makam musical training, served as participants for the study. And a total of 10 musical excerpts were used during the experiments, each of which had a duration ranging from 60 to 75 seconds. And since the last two excerpts were accidentally skipped in 5 sessions, all the following analyses done were done on the first 8 tunes, and the information given in this table belonged to these tunes. And excerpts were originally taken from the first couple of measures of 10 different makams and most common makams and rhythmic patterns that were written in 5 of the most common makams and meters of traditional Turkish music. And the purpose of having this equal amount of balanced representation of different makams and patterns was just to ensure a good representation of the variety within the traditional musical culture. And the all tunes were written by using a specific notation software, especially created for microtonal works, which allows the user to play back the score with accurate intonation by using sound samples of Turkish music, acoustic instruments of Turkish music, and the tunes were then recorded by Kanun sound sample. Kanun is a different type of zither used in Western countries, and then converted into high-resolution MP3 files later to be used within the setup program. And all the materials of the study were presented via binaural headsets. And the experimental setup for the segmentation trials was programmed by using JavaScript, and we decided to add a visual component to each task without providing any visual information about the temporal and spectral aspects of the tune. And each tune was presented 4 times. In the first trial, they would simply listen to the tune to familiarize themselves. And during this presentation, as you see on the screen, there was a horizontal line which was visible during visible moving from left to right to mark the unfolding of the tune. And in the next 3 trials, a vertical bar instantly appeared on the horizontal line in different colors as the participant marked their boundaries, and these the colors of the bars were different: green, blue, and violet, respectively. subsequent trials of each tune, the participants were able to see their earlier segmentations as they were attempting to mark their new ones. And this session was conducted in a strictly standardized fashion without any interruption. And it took 42 minutes and 4 seconds. And when we come to the results, there was no significant difference between musicians and non-musicians in the average number of segmentations per tune, and even the average standard deviations of number of segmentations per tune for musicians and non-musicians were rather similar to each other. Yet, of course, non-musicians showed more variation among each other in the number of segmentations per tune than musicians. In general, musicians and non-musician segmentations locations in milliseconds, when we look at here for all tunes, overall demonstrates good convergent segmentations in each group, and more importantly, good converging segmentations across musicians and non-musicians. And since the strongest within and between group convergences appeared to have occurred in tunes 5 to 8, we decided to create histograms for each of these tunes. This is for tune 5, tune 6. Just even a purely visual evaluation of these histograms suggests a considerable overlap in the location of the most frequently indicated boundaries, like this. And we also compared the responses of the participants with the predictions of the three models, with our proposed model, as well as with the local boundary detection model and Penny and Polanski's model. And the aim of this comparison was to see how well these models predicted the boundaries of the participants. But since we took the results recently, this will be a preliminary consideration only, not the whole. The three models are tested individually for all monophonic tunes, and the results in general show that the proposed model offered the best congruence with the listener's indications, while Tini and Polanski's model offered the worst, except in tune 4, in which it outperformed local boundary detection model in predicting certain perceptual locations. The boundary locations suggested by LBDM with strengths superior to 0.50 are coincided with some of the perceptual segmentations across 5 tunes, whereas the perceptual locations indicated for the rest of the tunes can be generally related to LBDM segments of lower strengths. And this table shows only the number of boundaries predicted by these three models that overlaps with the boundaries indicated by the participants. And in general, the perceptual segmentations indicated by the participants for 8 tunes also show that the inter-onset interval was a prominent dimension for all participants in determining a potential boundary, with a few exceptional locations in certain tunes which were only perceived by musicians. And this is in fact highly related with the structure of the, which can be highly correlated with the related makam structure of the tunes. A comparison for one specific piece, Nihavent, this is Nihavent makam in kar form, can be seen in this figure. I will quickly explain the symbols here. The listener's boundary indications, boundary decisions are shown by triangles about the staff, blue for musicians and red for non-musicians. And due to the real-time setting of the experiment, the boundaries of the participants have been relocated on the score in the post-experimental phase. I have to note that. And the boundaries based on pitch intervals proposed our model are shown by red brackets. The others are with red triangles, and the onset boundaries are blue. The rest boundaries are shown with green triangles, and the strongest boundaries are shown by applying thickness or darkness to the symbols, or darkness or lightness to the colors. So in general, we observed that the Sorry.
We're almost out of time.
Yeah. Okay. So, in general, we observed that the onset intervals indicated as boundaries by the participant correspond to the central or dominant scale degrees of the related makam structure of each tune to a large extent. And as you see here in this slide, G is the central scale degree, and D is this dominant scale degree of this makam is shown with colored triangles. And B is the third scale degree, which is also very important in makam structure. In certain makams is shown by gray rectangle. So since we ran out of time, I will not play this excerpt, but we actually located both participant boundaries and the ones predicted by the model on each score of each tunes, but we prefer to show the scores of nearly the last 4 tunes here, as you see. So this research is still in progress. These are just preliminary considerations. We will add some details to the results and conclusions. We have much research and thing going on right now, and these are the first ones. So thank you.
Okay, thank you for this great presentation. Are there any questions for the speakers?
Thanks. Did you check the grouper model segmentation algorithm by Temperley? Because there's a paper by Pierce et al. Who did something similar with pop songs. They had users, subjects, check segmentation and compared a lot of models. And the best one was the grouper model, the second best was the EDM, the third best was the local boundary detection model. So, to my experience, grouper is the best what you can get for segmentation. Are you planning to compare this? Would be interesting how it works on this kind of music. And second is, one remark is the absolute time frame, because if you would double or half the tempo, your model would give the same results, which for sure would not give the same segmentations with listeners.
It would not with the listeners?
If you play it twice tempo or half tempo, the segmentations of the listeners would be not the same.
Is that so?
I understand.
Okay, depends on the inertia of reactivity of when you segment the interface.
Is that something you found, or is this something you expect? Because this is played in its real tempo.
It's something I expect, because it's like such a difference time. How many notes, how many times you have element to get it to your working memory is on absolute time.
But of course these pieces are developed for listeners, so they have their natural tempo that's adjusted to the working memory capacity.
But the algorithm is time invariant.
Right, that's right, yes.
Do we have any last question? Okay.
Would you include dynamics? Would you include dynamics?
They could be included. The way rest is included, and this rest is just this little silence that you note, and it's already something more timbre, but then we could include dynamics.
Okay, then let's thank the speakers once more.